and I'll put that onto, there we go. So I'm going to talk a little bit about advances in additives for industrial waterborne coating formulations. And as I said, nothing stays the same very long. And in terms of coatings, then I say the pandemic has not influenced the way people formulate. But over the last 20 and 30 years, the regulatory environment that we operate in has changed quite significantly. And the landscape of regulatory regulations regarding coatings and the use of coatings has exploded in the last few years. I'm not going to talk about these directly in detail, but just to give an idea of what's been driving development in waterborne coatings. Initially, restrictions to VOC content have been driving this development and still are doing. We have the implementation of REACH in Europe. We have the US TSCA regulations and the ISCSC in China. And basically the same more or less for every country in the world. And this has an effect on what you're allowed to put into paints and what you're allowed to do. And this has an effect on how the paint performs when we start to change raw materials. These lists have extended in recent years to specific substances, and we have in Europe, we have the substances of very high concerns. We have substances that are banned due to and are very persistent and very bioaccumulative, and new regulations coming regarding sustainability, bio-based coatings, and carbon footprint is things that all the raw material suppliers and formulators also have to take into consideration. When we're developing additives, then we have to take into consideration all these aspects. The additives business is a global business, and so all these things need to be taken into consideration. This is creating an ever-changing world for people formulating paints and the raw materials that are available and the regulations that paints formulations has to comply with. So the development of waterborne coatings is driven to a large extent by these things. It's also driven, as the previous speaker was talking about, by developments in application equipment. Spray equipment has become a lot better, and industrial application of coatings has become a lot more effective. So the changes in application equipment also make additional demands on the coating formulation. At the end of the day, however, and also as the previous speaker was saying, then waterborne coatings, industrial coatings, are a solution to some of these issues. Whether these providing better performance depends a little bit on the choices that are made during formulations. The basic parameters, though, of what a coating has to do remain unchanged. They're very much the same. And the basic formulation challenges here are substrate wetting, adhesion, intercoat adhesion. The coatings still have to have an ideal appearance. Color is very important, durability, application properties, and not least cost of coatings and raw materials. So all these, the physical and application properties need to be taken into consideration. As regulations change, then the raw materials that you're allowed to use and that are available to use also change. And the choice of, in particular, additives to influence substrate wetting, adhesion, appearance, all these properties at the same time also has to change, and that's what Dynea have been doing with our Dynoadd additive product range. So the products I would like to show a little bit more details about today are new additives for waterborne formulations that are taking into consideration all these environmental and also regulatory aspects, but also in terms of performance. They need to perform better in aspects than the raw materials that were available previously. So the products I'm going to talk about is a Dynoadd D-960. It's a pigment dispersing agent for specifically for carbon black. Dynoadd D-962. It's also a pigment dispersing agent for inorganic and organic pigments, and also Dynoadd F-461, which is a polysiloxane wetting agent, which is SVHC label free. This is a product without any substances of very high concern, which is now also a requirement, increasing requirements for. So D-960 is a pigment dispersing agent. It gives fast grinding time. It gives excellent reduction in viscosity of the pigment paste. It gives high color strength and gloss, and gives a very high blackness and jetness values from the pigment. It gives excellent performance across the board, and I'm going to show you some examples with two carbon black pigments, Emperor 2000 and FW 200, and showing how that the product performs in relation to some benchmark additives as well. So basically a little bit about dispersing agents. Dispersing agents need to wet pigments. They need to remove air that's absorbed onto the surface of the pigment particles. They need to be able to disperse and also to stabilize dry pigment powders in liquid formulations. And this is done in several steps, as I'm sure most of you will be familiar. The first one is to wet the surface of the pigment, agglomerates, and to remove air from the surface of the pigment particles. The second process is to aid dispersion and to break the agglomerated pigment particles into individual pigments. And once these have been broken down by mechanical forces, then a pigment dispersing agent needs to stabilize the individual pigment particles to avoid coalescence and agglomeration process. So, pigment dispersing agent should have complete coverage of pigment surface. It should have strong anchoring groups to make it stick to the pigment particle surface. And it needs also to be soluble in the media that you're dispersing into. In this case, I'll be talking about water as the medium. And these chains need to be, as I said, soluble in water so that they extend into the media and provide a protective shell around each individual pigment particle. So that's basically the principles of pigment dispersion. In practice, it's not always easy as in theory. So Dynoadd D-960, we've chosen two carbon black qualities to showcase here. One is Emperor 2000, which is a high jetness pigment black, and the other one is an all-round FW 200 pigment. So with Dynoadd D-960, you can obtain low viscosity liquid pigment pastes, which have stable viscosity after 14 days at 40 degrees. So for Emperor 2000, we can see here, this is a pigment paste, 20% carbon black in water, and you can see the viscosity is very, very low. And also compared with with the benchmark additives that we've used to compare with, the stability after 2 weeks at 40 degrees is also very good. The pigment paste viscosity is unchanged. And for another carbon black pigment, the Orion FW 200, then we can see Dynoadd D-960 is giving a low initial viscosity and has some increase after 14 days at 40 degrees, but the pigment paste is still liquid. The benchmarks C and D in this graph here increased quite dramatically in viscosity and became thixotropic, so they were no longer liquid, and that's why they've been greyed out there. So for pigment paste dispersion, at the end of the day, it's all about colour strength as well. How much colour do you get? And for Dynoadd D-960, against one of the benchmarks here, we can see that the amount of dispersing agent needed to achieve a high blackness and jetness is significantly lower than the amount of additive dispersing agent needed to for the benchmark E to achieve the same colour. This is in an industrial polyurethane dispersion-based coating, and as we can say, with similar performance with a lot lower additive loading. At the similar additive loading at 70% dry dispersing agent based on the weight of carbon black, then D960 gives far higher blackness measurements, a lot blacker coatings than the benchmark does at the same additive level. So this is improved performance. So this is higher blackness with the same additive loading. So basically, Dynoadd D-960 gives a higher colour strength compared with benchmark E. And in comparison with the Emperor 2000, Dynoadd D-960 gives approximately 9% better colour strength for the same amount of pigment paste. And for FW200, then 4% better pigment paste. And here you can see pictures of drawdowns, so you can actually see the colour differences between, on the left-hand side, the pigment coating using pigment paste made with Dynoadd D-960, and on the right-hand side of the drawdown with the benchmark product. So you can see we get significantly more colour, and at the same time using less active additive dispersing agent. So that gives benefits in terms of using less pigment to get the same amount of colour, and also using less additive and reducing total cost. So these are some advantages with for dispersing agents for water-based systems. The second product I wanted to share with you today is D-962. This again is based on the same type of novel polymer technology. These are polymer-based additives. The D-962 is developed to have a broader range of dispersing activity against a broader range of pigments, which I will show. So again, this one gives excellent viscosity reduction. It gives high colour strength and gloss to the final coating. We get good pigment paste stability, and the product is effective for a wide range of pigments. Like I say, these polymers have very good pigment affinity. They absorb very strongly to pigment surfaces, and they also provide very good effective steric stabilization, which means you have stable pigment paste and very good color reproduction in the final coating. One of the first properties is these dispersing agents, D-962, gives very good viscosity reduction and very good pigment paste stability. So these are some examples. We've used pigment yellow 74, pigment green 7, pigment blue 15.3, and pigment red 170, and the pigment loading and the percentage weight of D-962 solids on pigment is shown in the table. And here we can see the viscosity, initial viscosity of the pigment dispersion, and also after 14 days of storage at 40 degrees. So we can see these are liquid, low viscosity pigment dispersions. They are also very stable, keeping their viscosity and rheology properties after 14 days at 40 degrees. Using these pigment dispersions gives in coatings, in a variety of coatings, gives high color strength, and again with a wide variety of pigments. These are results for using pigment pastes, as I showed previously, in white base coats, and these are shown in our white industrial base coat, and also a white architectural paint. And we show the improvement in color strength of the D-962 pigment paste compared with that of a competitor benchmark product. So here we're seeing all these pigments in the yellow, green, blue, and red pigments. Then the pigment paste with D-962 is giving higher color strength than the competitor product. And these on the right-hand side, you can actually see the drawdowns. It's not always easy to see on screen. It varies a little bit from screen to screen, but hopefully you can see the D-962 is giving a stronger yellow color, a stronger red color, and also a stronger blue color on the right-hand side of these drawdowns. So for a variety of organic and inorganic coatings, then D-962 again is giving more color for less pigment dispersion use. Pigment dispersions with high pigment loading, which is also a very good cost driver. So I was a little bit about pigment dispersing agents. The third product that I wanted to show was a product that we will be introducing in the very near future, in a matter of next month or so. This is the Dynoadd F-461. It's a polyether polysiloxane, and it's which traditionally these types of products have contained cyclic byproducts, cyclic silanes, which are very persistent and very bioaccumulative, and we have restrictions on those now in Europe. So this Dynoadd F-461 is a product where those problem substances are absent, and it has no SVHC labeling. It's a substrate wetting and leveling additive. It generally gives low foam formation in relative to other wetting agents, and it gives a coating surface with high slip, which is very helpful for improving scratch and mar resistance of a top coat, for example. So Dynoadd F-461, it significantly increases substrate wetting. On the right-hand side, left-hand side of the screen, you can see a coating without any added wetting additive, and you can see that coating has shrinkage, and it gives this window frame effect. The addition of 0.15% of Dynoadd F-461 to this coating gives significantly improved wetting of the substrate. And substrate wetting is critical in terms of both in terms of final appearance of the coating, but also in terms of the ability of coating to achieve good adhesion to the substrate. So this wetting is a very important parameter. Wetting agents in general can also improve foam stability and create more foam. And everybody knows about surfactants and soap. They give good wetting, but they also have a tendency to generate a lot of foam. That's something we've been very observant of when developing these products. And Dynoadd F-461 performs very well in that context. So Dynoadd F-461, it reduces foam formation in relation to the coating. Again, without a wetting and leveling additive, you can see there's a huge amount of foam there. It's typical for waterborne coatings. The addition of a wetting additive doesn't improve that. It doesn't give more foam. In this case, it gives actually less foam. So That's a very nice benefit for getting good wetting and relatively low foam formation. Having said that, the product is not a defoamer by any means. It's still a wetting and leveling agent, but it has a very positive effect on foam stability. Dynoadd F-461, again, it significantly increases substrate wetting, reduces foam formation, and it gives us a coating surface with very high slip, and again has no SVHC labeling and is fully compliant with all the regulations that I showed on the first slide. So we managed to maneuver in that landscape as well with this product. So that basically gives a very short introduction to some new products which are helping to the paint formulator to maneuver in an ever-changing world, to improve performance, to improve color, and hopefully satisfy all the environmental requirements that are needed for today's modern coatings. So with that, I'd like to wrap up and to thank Mr. Nagar with the organisers for helping to facilitate this. I'd also like to thank my colleagues at Imchemex Marketing, Mr. Govind Ketan and Mr. Swapnil Hajamis, and also my very good colleagues here at Dynea in Norway, to Gabriel Alvarado, Charlotte Testa, and Camila dos Santos, who are working here in Lillestrøm developing these products. So thank you to you all, and thank you to all you people attending the conference for listening. So thank you very much for your time.